In this module, I'm going to introduce algorithms. I'm going to start discussion. We will have several modules that we will have on the topic of algorithms. The goal of this module is just to introduce what an algorithm is and what are some of the properties we want in an algorithm. So what is an algorithm? An algorithm is a finite set of instructions. A few important things. Number of instructions in your algorithm must be finite. For solving a class of problems on a computer that has the following properties. Property number 1 is being definite. That means each instruction must precisely define what it means. You can't have some vague instructions that could have different meanings in different times. Each instruction must be sufficiently basic. In other words, you can't have instructions that make you do stuff that is too complicated. You can't have an instruction that says solve world peace and then do something. You can't have that. Third requirement is for the whole algorithm itself, and it is that it must always terminate. So when you start executing the instructions, you might have some kind of loops, but no matter that, you must always terminate. The concept of algorithm that we use today is based on the notion of Turing machine that Alan Turing identified. Now, the way Alan Turing identified this Turing machine was basically, he said, the kind of instructions that you can have are basically a lookup table. That is, you have a program and you have a tape, and in every step the program can do exactly one thing, which is it can read one location on the tape that it is looking at. Then it can look up its table to figure out what it should do, and what it can do is either move left or move right or change the symbol that it is looking at currently. That's all it's allowed to do. Either it can write and move left or right. So we can see that each instruction is precise. It doesn't have different meanings in different contexts. Each instruction is sufficiently basic, and now the goal is you need to write a program in this environment that will always terminate. You can look up a simulator for the Turing machine. You can look up these other links as well. Now, in our context, we want to use a little bit more operations than what Alan Turing defined, because it will make it easier to write our programs. So in our program, we will assume that we can do stuff like addition, subtraction, multiplication, division. We can shift a number. We can compare two numbers to see which is bigger. Now, you could ask the question, why stop there and why not ask for some more things such as square root of n or the nth root or sine, cosine, log, etc. It turns out that yes, you could add those if you wanted, but we can compute these functions in terms of the basic functions that we have. Essentially, if we have addition, multiplication, subtraction, division, we can do all of these things by figuring out certain properties of them. Let's look at an example. Here we have two positive numbers n and b. We want b to be greater than 1. We're going to divide n by b. This will give us a quotient and a remainder. we're going to print the remainder, and if q is 0 we're going to stop, otherwise we're going to treat q is equal to n and go back to step 2 and start dividing this number again. So we're going to write this in a slightly more formal way, and we are going to try this for two specific numbers, say n is equal to 13 and b is equal to 2. Your job is to figure out what happens, what gets printed, and identify what the output is going to be. These are some other examples of the algorithms. So here you have a very simple thing. Carry out this calculation, 3 plus 2 times 4. You need to figure out, you need to do multiplication first, then addition, etc. You can have algorithm for something like find the max value in this list. Once again, we have reached the check before you go ahead slide. The key thing I want you to get from this video is what are the key characteristics of the algorithm. And as I said in the previous slide, we want each instruction to be precise. We don't want ambiguous instructions. Each instruction must be simple. Basic things like addition, subtraction, etc., not complex instructions that would need to be implemented by other instructions. And another key characteristic is an algorithm must terminate.